Today we're going to look at the t-distribution. What you have before you is just a reminder of the formulas that we've done so far. The z-distribution uses the central limit theorem, and you have z sub alpha over 2. You always use that when n is greater than or equal to 40. Greater than or equal to 30. Don't forget that you have your special numbers you need to remember. 90% is equal to 1.65, 95% is 1.96, and 99% is 2.58. You're using the average plus or minus z sub alpha over 2 over the standard deviation divided by the square root of n. Also remember the proportions or the p-value or the p-test that we talked about yesterday. If you do not have the standard deviation, you must use this formula. P hat, which is your proportion or your percentage, that's the percent of your samples, and we find P hat by doing x over n. Remember we talked about that yesterday. P hat is x over n, or number of yeses over the total. And then your Q hat is 1 minus P. And so we fill those in, and remember that you need to be careful about parentheses with this. You need a parentheses here, and then your calculator automatically gives you a parentheses here, so you must close that down there. Today we're going to look at the t-distribution. When we do the z-distribution, we're always looking at an n greater than 30. So if my n is greater than 30, what happens if it's less than 30? Well, I'm going to do a t-distribution. I've written the formula down here at the bottom. So instead of using the population average, now I'm using a sample average, plus or minus, and notice that this letter has now changed. That makes this different. Alpha over 2 times S, which is the sample standard deviation, over the square root of n. So basically you're taking this, the formula for the z-distribution, you're turning it into samples, but now we're using a different number here. These over here do not apply to the t-distribution. They only apply to the z-distribution and to the proportion distribution. That's the reason we did them together. So for the t-distribution, we're going to look at that formula today, and there's a couple of different things that we need to look at. So the first thing we need to fill in on our notes is the t-distribution characteristics. It is like the z-score in that it is bell-shaped. It must be a bell-shaped curve. The mean, the median, and the mode are all the same. It is symmetric about the mean. And the curve never touches the x-axis. Okay, so if we're looking at the curve looks very similar as when we do the z-distribution. So this is my mean, my median, and my mode. The differences are that the variance is greater than 1. In other words, if you have omega, it's going to be greater than 1. It is based on a family of curves, not just one curve. And that family of curves gives us what's called the degree of freedom, which we're going to use for our new chart. Okay? The third thing that is different is as a sample size increases. It approaches the normal. That's why it mirrors the z-test, but we can't use the z-test because we don't have enough samples. Because we know that the N for the z-test has to be greater than or equal to 30. Okay? The degrees of freedom is the thing that makes the t-test or the t-distribution a little unusual. The degrees of freedom are the number of values that are free to vary after a sample statistic is computed. So again, we're talking about samples, not about populations. They tell the researcher which specific curve to use when a distribution consists of a family of curves. Now let me draw a picture so you understand what I mean by a family of curves. So if I have a distribution and I draw its curve, it may look something like that. Then I may do another sample, and when I do it, it may look something like that. Then I may do another sample, and it may look something like that. Okay, so that is my family of curves. Well, how do we find the degrees of freedom? If it's a family of curves, how do we find the degrees of freedom? First of all, we abbreviate degrees of freedom DF. And it is always the number of things in the sample minus 1. Okay? So our formula, as we said just a minute ago, is x bar plus or minus t sub alpha over 2 times s over the square root of n. Now, we have to use a different formula. We have to use a different distribution table because we're using degrees of freedom. So in the green book on the shelf, the table is on C16. Okay, it is the T distribution table, and you'll notice that on the left-hand side it has dx, so that's your degrees of freedom. So let's do something that uses the formula. It says find t sub alpha over 2 for a 95% confidence interval when the sample size is 22. So n is 22. This is a 95% confidence interval. So the first thing I need to find is the degree of freedom. Well, we said that was n minus 1. So my degree of freedom is 22 minus 1. And I want a 95% confidence interval, and it has 2 tables. Okay? The 95% is going to be above each of those. So this is the table that you have in your book. And so I'm going to go down to the degree of freedom of 21. And then I'm going to go over to the 95% column, which is right here. And that will be 2.80. 2.080. 2.080 will be my answer. So t sub alpha over 2 is 2.080 for that particular question. Okay, let's look at another one. 10 randomly selected people were asked how long they slept at night. So N is 10. The mean for my X bar was 7.1 hours, and the standard deviation, which is S, is 0.78 hours. Find the 95% confidence interval. So my formula is X bar plus or minus 2 sub alpha over 2 times S over the square root of it. Okay, so the first thing I need to find is I need degrees of freedom, and that is 10 minus 1 or 9. So I know my mean is 7.1 plus or minus. Now I have to use my degree of freedom of 9 to find this. I want a 95% confidence. So I'm going to go to degree of freedom of 9 and across to 95%. And my answer is going to be 2.262. Okay, so 2.262 times the standard deviation, which is 0.78, divided by the square root of 10. Now notice this is N, it's not the degree of freedom, it's N. So this is 10, not 9. Okay, so when you put that in the calculator, you're going to find out that this is 6.542 for the minus part and 7.658 for the plus part. Okay, so be careful about parentheses and make sure that you can compute that. Okay, all right, for the last one here, we're going to look at data that we already have, and I'm going to give you the X bar. X bar is 7,041, and S is 1610. The number of things in my list, 1, 2, 3, 4, 5, 6, 7. So there's 7, so that means my degree of freedom is 6. So 7 minus 1 is 6. So the first thing I need to find is my T sub alpha over 2. So degree of freedom is 6, and I want 99%. So degree of freedom is 6, and then over to 99%, and I should get 3.707. Okay, so 3.707. And I'm going to fill in my formula, 7,041 plus or minus 3.707 times 1610 over the square root of 7. So when you do the minus part, you should get 4,785 to 9,297. This is the T distribution. Please make sure that you have completed your notes and turn those into the box.